One question you may be asking yourself is, why do we want rational exponents? What purpose do they serve? Well, you can oftentimes do things with rational exponents that you probably could do them with radicals like these, but it's a little bit easier to do them like this. So the rule with rational exponents, this is one of the things that they're giving us, so probably put that in your notes, and that is if you are multiplying two numbers with the same base. Now that's important, they must have the same base and different powers, you would add the powers. So just as an example, I'm going to start with a fairly small number. Like, I'm going to start with 2 because that's probably the easiest one to start with. So 2 to the third power and 2 squared. So 2 to the third power is 8 because it's 2 times 2 times 2, which is 4 times 2. And we have 2 times 2, which is 4. So 8 times 4 is 32. Now, if we were to break 32 down into a base 2 number, so a number with an exponent but a base of 2, it would be 2 root 5. So 2 plus 3 is 5, and 2 to the 5th power is 32. I hope that kind of shows, but both of these are the same thing, and I can kind of jump from one to the other. Doesn't really matter. It still gets you to the same spot, but I'm just showing you why it works. So let's go ahead and see how we get it to work. So here I have two numbers with base x, and I have rational exponents. So we're going to have to kind of take a page out of fractions, which you probably should have learned in junior high, but if you forget, in fractions, if the bottom number is the same, or what we call common denominator, then we can add the numbers together. We can add the top numbers. So in this case, 5 is our denominator, our bottom number, which in this case they are common. They are the same. So it stays 5. Let me make that 5 a little bit better. Maybe I need to increase the size of the base. That way it's not as confusing. Anyway, now we can add our top numbers. So in this case, it would be 4. 1 plus 3 is 4, so that's how come I have a new top number of 4. And the bottom number is 5. Now, in fractions, you don't really change the bottom number after you add or subtract them. The bottom number is kind of a placeholder to show how much of something you need. I could probably show you with a picture, but that might take a while, so maybe I'll save it for the end. But anyway, there we go. So that's it. We have a much simpler exponent number when we took care of our operation of multiplication. So let's go ahead and do this one. Now, if it helps, which it probably should, I'm going to put a 1 right here. That 1 will help me keep track of what power that x is in. So x, I'm going to start with the exponent first. I don't normally do that, but sometimes my exponent numbers don't quite look the part. There we go. Now I know how big to make the x. So there we go. So x to the 1 over 4 power, and don't forget your index becomes the bottom number. And it's still multiply. We haven't changed anything. Now remember, we're multiplying these, not adding them. But when you are multiplying exponents, you treat it like you're adding them. So we're going to put x here. Now I'm going to have 2 to the 3 power. And like I just got done saying, you treat it like you are adding them, but in this case here, we don't have a common denominator. Our bottom numbers are not the same. One is 4 and the other is 3, so I have to make them the same. Now again, if you forgot fractions, okay, well, we're going to have to kind of go over it a little bit. But I need the bottom numbers to match. So I need a new number that can divide by 4 and divide by 3. What we call common denominator, or least common factor, or sorry, least common multiple, which is what is the smallest number that 3 and 4 meet up at, which in this case I'm going to go ahead and tell you that it's 12. Now 12 can be divided by 4 and 12 can be divided by 3. That's important because 4 and 3 are factors of 12. So now let's work with our first number here. So first number, I have to make the bottom number from 4 into 12. So that means I triple this number. So I'm going to triple or times it by 3. 3 times 4 is 12. And I have to do the same thing to the bottom number. Now I'm going to show you that it's the same thing. I know one thing that happens in math is people always say, oh, it's confusing. Okay, but it's actually, most things in math are a lot simpler than you think. It's just sometimes when you can't really figure out how you get from one spot to another, it can be confusing. So let's look at our fraction, 1 over 4 and 3 over 12. So 1 divided by 4. Now this one should be pretty easy. 1 divided by 4 is 0.25. Now remember that 0.25, if I were to take 3 and divide that by 12, hey, what do you know? I get the exact same number of 0.25. They are the same thing, okay? They look different, but are the same thing. And let's go ahead and try this one here. Now this one's going to be a little bit of a different one. But let's look at 3 and 12. So what can I do from 3 to go to 12? And I need to multiply it. So in this case, I would need to multiply 3 by 4. 3 times 4 is 12. So times it by 4. Now do the same thing to the top number. Take 2 and times that by 4. So you get 8. And again, just to show you there's no tricks going on here, let's take 2 divided by 3, and that's going to be 0.666. Now if I do the same thing and take 8 and divide it by 12, it's the same thing. So again, in math, try not to get confused. Okay, so again, I know English is like this too. You can have several words mean the same thing. And sometimes even in different languages. So some people may call them shopping carts, other people call them shopping trolleys. They are the same thing. They are just different words. Alright? So looks different but means the same thing. Now that our bottom numbers are the same, I can go ahead and add them. So 3 plus 8, which again, remember, you add the number. So in this case, I have x to the 11 over 12, and we are done. I'm going to go ahead and box my answer to show that we're done. There we go. And that's if you are multiplying numbers. If you are dividing numbers, you follow the same steps, pretty much the same process, except we are now subtracting. We treat it like we are subtracting. And again, fraction just means division. Okay, don't be scared of fractions. I know that when it comes to things that worry people or scare people the most in math, it's usually fractions. But just like any scary animal, once you know that it's not out to hurt you, it's not as scary anymore. So fractions are not out to hurt you, okay? If anything, fractions are more scared of you than you are scared of them. So let's go ahead and break this down. So first thing we got to check is the base is the same. So my base is x for this one, and they are both x, which is good. X, and Go ahead and go with 7/10, because remember, it's first number divided by second number, which it's just like subtraction. So subtraction and division, you can't change the order. You can't change which number is the first one. The first one is, well, the one you start with, and the second number is the one you subtract or divide by. So my second number is 6/10. Now it's supposed to be a 7. Oops. I need to get a better writing device. Now, I didn't write the same base twice. I could kind of do what I did here and add them, but I wrote 2 bases. But in this case here, I'm just going to write the subtraction and keep the same base. So 7 minus 6 is 10. And there we go. If we look at the, well, in this case, it doesn't say what we should do in the directions. The directions do not say express in radical form or express as rational form. So if you remember on the exercise where we moved it from one type to the other, it doesn't say which one we should move it to. So we could probably leave it like this. But if we look at the clue here, we have a number with a base and an exponent. So we're going to go ahead and leave it in rational exponent form. So sometimes, even though the directions don't say it, you should probably look around for clues that kind of give you a hint what your answer should be. Alright, next one here. So this one's going to be a little bit of work. We're going to have to change things a little bit. So, let's see, how is the easiest way to explain this? Let's go ahead and put with x. Now remember, this top number, the inside number is our top number, so in this case 5/6. The index is the bottom number. Alright, so just remember that. And I've said that almost every part of this lesson. Index is the bottom number. So there you go, 5/6. Now I'm going to subtract it from this one here. So top number is the inside number, and the index is the bottom number. Again, index is bottom number. So let me go ahead and put x. 5 minus 2, right? So 5 minus 2 is 3. And my bottom number is 6. And again, just like with all of these, when you're adding or subtracting fractions, you do not change the bottom number. So you do not treat this as 6 minus 6 is 0. No. Bottom number stays the same. And I could tell you why, but that would pretty much be an entire lesson on its own. But we're not quite done yet. Now, if somebody, well, the example I always give for this one is if somebody wanted a 3/6 socket wrench, could you give them one? Well, yes and no. Alright, so I know most of you guys are not really tool people, but 3/6 is the same thing as 1/2. One half is the same as 3/6. So if you have a fraction, in this case 3 and 6, which can both be divided by the same number, you divide both your top and bottom number by that same number, and you should be able to get a simplified fraction. So 3 and 6 are both divisible by 3. 3 divided by 3 is 1, and 6 divided by 3 is 2. And again, this is another one of those examples of 3/6 is just 0.5, and 1/2 is also 0.5. So again, don't get confused. It's the same thing, it just looks different.